So now, when it comes to a collision, if you have got two objects which are colliding, okay, all right. So when two objects collide, a collision can either be elastic or inelastic. Okay, so what's the difference between these two types of collision? Now, in elastic collision, you need to know that momentum is conserved. And also in inelastic collision, momentum is still conserved. Meaning that the initial momentum, the sum of the initial momentum is equal to the sum of the final momentum. And then in elastic collision, kinetic energy is also conserved. Okay? But in inelastic collision, kinetic energy is not conserved. Not conserved. So this is what just makes these two types of collision different. Now, inelastic collision can also be perfectly inelastic. If you hear perfectly inelastic, meaning that two objects struck each other and they stuck, like they stuck. That's a perfect inelastic collision. So in such a collision, kinetic energy is not conserved. And let me just look at an example of an inelastic collision, and then we're going to be done for the day. All right, let's say we have got this man. Should I use a person? Let me use a block. So let's say we have got this block which is 20 kg, and it is let me use, okay, it's fine, 20 kg. It is moving east at less than 10 meters per second. Okay, it finds another block, another block, but this other block is moving in the opposite direction. Okay, this block is moving in the opposite direction at 5 meters per second. And this block, let's say, is 10 kg. And when they strike each other, okay, they get to stick. At the end, they stick and they start moving as a unit. So when they hit each other, they stick. They start moving as a unit. So whatsoever direction, let me say they are moving like this. So now we're going to have two questions. The first question, calculate the final velocity at which they are moving as a unit since they stick. Calculate their velocity. And then the second one we are going to answer is, since we have said kinetic energy is lost in this kind of collision, which is inelastic, we are going to calculate the loss in kinetic energy. Okay, let's work out these two questions. So we're going to start. We know that momentum is always conserved in any kind of collision. So momentum before impact. So let me call the 20 kg object as m1, the 10 kg object as m2. So momentum before impact should be equal to momentum after impact. So m1 multiplied by u1. U is representing initial velocity for m1. And then plus m2 multiplied by the initial velocity of 2. This should be equal to m1 multiplied by the final velocity of 1 plus m2 multiplied by the final velocity of 2. Please, momentum is conserved. You use the total. Alright, the total momentum before impact is equal to the total momentum after impact. That is what we call conservation of momentum. Okay, now the only thing here is, look at this. At the end, finally, these are moving as a unit. Because they're moving as a unit, they are going to have the same velocity. So v1 in other ways is going to be equal to v2. Why? Because they are moving together. So this equation is going to change. Instead of me writing it like that, I'm going to write it as m1v plus m2v. Now, since v is common, I'm going to factorize it. So I'm going to say m1 plus m2, and then at the and I'm going to write v. So just add these two masses and then multiply by the velocity because they are moving as a unit. That will be the momentum at the end. So m1, you can see the momentum, the velocity is what? So again, I'm going to take everything that is in the direction the positive x-axis as positive. So m1, the mass is 20, the velocity is 10, plus m2. You can see mass 2, that is 10. The velocity, who can tell me the velocity? Lista, can you help me with the velocity? What is the velocity for m2? Yes, Karist. Okay, so this is going to be negative. This negative is very, very important. So immediately, if you don't put that negative, you get the question wrong. Because these are moving in opposite directions, okay? So you expect their velocities to be different. And we are taking motion in this direction as negative because that's towards the negative x-axis. Meaning that if this object hit another object which was going like this, would have used positive velocity because they were moving in the same direction. Okay, so that is going to be equal to m1 plus m2. m1 is 20, m2 is 10 multiplied by v. So 20 times 10, that's a 200, minus 10 times 5, negative 5, that's a 50, to be equal to 30v. 200 minus 50, that is a 150, is going to be equal to 30v. Divide both sides by a 30 to remain with a final velocity. So find that the final velocity at which they are going to be moving as a unit is going to be 5 meters per second. So this is the velocity at which they are moving. Right. So this is for the part A. And then for part B, you want to find the loss in kinetic energy. Now you know that according to conservation of energy, initial energy before should be equal to energy after. Like that's something that we've always known. Okay, initially this one is moving, right? M1 is moving. Meaning that what kind of energy that is possessed? What kind of energy is possessed by something in motion? Caristo, yes, go on. Kinetic energy. Good. It's kinetic energy. So we're going to say kinetic energy is found by what? Half m. Now I'm going to say m1. Okay, m1, and then u1 squared. Why am I using u? Because we're using the initial speed. We know kinetic energy is half mv squared. Now that v is simply velocity. Now this is initial velocity, so that's why I'm using u. Okay, plus the initial kinetic energy of the other object. So that is going to be also half, but that is m2. So that is going to be m2, and then the initial velocity 2 also squared. And this should be equal to, now remember at the end, these are moving as what? As a unit. Okay, they are moving as a unit, so we're going to say half. We are going to use their combined mass and their combined velocity squared, and then plus that loss. Okay, the loss is going to be this side. Why? Because obviously something that has lost is supposed to be a product. It's lost. So when you add the energy before, it should be equal to the energy after plus that loss. So when you add that loss to the energy which you find at the end, it should give you the total energy as the initial energy. Why? Because that loss, for example, initially maybe you had 20 joules of energy, and then here by this formula just find 5 joules. Where is the other one gone? Where is the 15 joules gone? It is a loss. So when you add that loss plus this energy, you should get the total. That's conservation of energy. Okay, so here now we're going to just substitute values. This is going to be a half m1, that is 20, u1, that is what? That is a 10. You square that, plus half m2, that is a 10. You can't see the screen. I think it's just a network. It's just a network that side. Okay, the initial velocity here. Don't worry, even this is just the question we're having. Going to send the session. Okay, now we put the initial velocity for the second one. The initial velocity is 5. Now energy, you don't even need to put a negative on the 5. Like negative 5 squared will still be positive, right? So for the energy, in other words, you don't care about the sign, the direction. So because we are squaring there. And this is supposed to be equal to half. Now this capital M is a combined mass since at the end they were combined. So that is 20 plus 10, which is a 30. And then the velocity at which they are moving together is 5. We are just from calculating that. And then plus the loss. So we know 2 can go into 20 10 times. 10 squared is 100 times 100, that is times 10, that will be 1,000. And then plus, we know 5 squared is a 25. That 25 divided by 2, that is going to be 12.5. 12.5 times 10, that is 125. Alright. And then we are going to, that is going to be equal to 2 into 30, that is a 15. We know 5 squared is a 25. So I'm trying to work things with so you can just punch that direct on a calculator. Okay, 15 multiplied by 25. That is going to give us 375. And then plus the loss. So I'm going to take all numbers to the same side just to make sure that everything is the same. So this is going to be 1000 plus 125. This is going to be 1025. No, this is going to be 1125. And then I'll bring the 375 the other side, becomes negative 375. And that is going to be equal to the loss. Meaning that the loss is going to be equal to, that is 1125 minus 375. We are going to get 750. Now remember, this is energy. This is given in joules. So this is how much energy has been lost in this kind of collision, because it is inelastic collision.